What's up, everybody? This is Ryan here, and in this video I'm going to be giving you an overview and kind of an examination of the pros and cons of using the Model View ViewModel Architecture, which is the architecture that we'll be using in this particular tutorial series. We'll also have a quick look at the packages and files for the demo application, just so you understand what's going on there. Now, before we look at this pattern in detail, I'd like to address what I consider to be a few misconceptions about not just Model View ViewModel, but software architecture, front-end GUI patterns in general. So I'm going to assume that most of you have heard about all kinds of different three-layer architectures. There's Model View Controller, Model View Presenter, Model View ViewModel, which Google seems to be putting all of their weight behind, or sorry, the Android team rather. And then we have other options like Viper, or there's Model View Intent by Hannes Dorfman. And I'm sure what most of you are wondering is, would someone please just tell me which one of these is the best architecture? Well, I'm going to try and burst your bubble right now because, in my personal opinion, the answer, and this opinion is fairly widely shared among senior developers, is that the project requirements at hand will dictate the best architecture for you. So one of the things that I've noticed over the years of trying several different approaches, different patterns, is that they work good in some situations and they can be counterproductive in others. Now, it's better to follow an architecture which doesn't really work super well for your problem requirements than no architecture at all. But what I'm trying to say here is that over time, when you know things about all these different patterns, you'll start to see, okay, well, this particular feature of this pattern is useful in situation A, but it's kind of a problem in situation B. So what I would like to do is basically explain in this video that Model View ViewModel is not an exception to that rule. It is not necessarily the best architecture for all situations, even on the Android platform, but it does have some benefits and some deficits. So what I would like to do is basically give you an idea of what those benefits and deficits are. And we'll get into that in a moment. But before we talk about that, I'm going to try to give you like a general overview of the architecture using a whiteboard example. Okay, so what we're going to do now is we're going to talk a little about the Model View ViewModel front-end graphical user interface pattern. Before I jump into this, one thing to note is that unfortunately, developers do not always consistently build these things the same way. So what I'm going to explain to you is a generalization. This is my interpretation of the Model View ViewModel architecture, but like I say, you're going to find different variations of this, and the most important thing for you to know is that different variations will work better in different situations. So what exactly happens? How does it work? So the first and most important thing, the defining characteristic of Model View ViewModel, in my opinion, is that essentially we have this thing called a view model in the middle, which encapsulates both the behavior and the state of the front end of the view, both the behavior and the state. So state being the data, and the behavior being what do we do when some event happens kind of deal. So the thing that's unique about Model View ViewModel is that this thing in the middle, the view model, you're not allowed to have this view model actually directly tell the view what to do. I'm not allowed to draw a line from here to here, which would be a dependency. So if you're doing Model View Presenter, you are allowed to do that. In Model View ViewModel, you're not, based on my interpretation. Instead, what happens is we basically have to have two dependencies, two different channels from the view to the view model. This is typically how we like to set it up. So one channel is just synchronous, and this would be the kind of thing where, let's say, for example, if we're coding for Android or whatever, the user hits a button, and then the view can just, just do a synchronous call, just a function call to the view model, hey, this button was clicked. So that's one of the ways it can communicate with the view model. The other way, and this is how it actually gets the data out of the view model, and this is confusing for some people, is that, do you see this eyeball thing here? This is my representation of what's known as the observer pattern. So you could use data binding. What I like to do is I like to use basically a producer-consumer relationship, or the observer pattern, it's called, between the view and the view model. So basically what I'm saying here is at the start, at some point, the view model will ask for observables. So it's going to ask for something from the view, and this thing that it's going to ask for something out of the view model. And when it gets that object, that observable object, I want you to think of that observable object as like a pipe that data pops out of at an indeterminate time. Whenever the data pops out of the pipe, whenever the view model asks the backend for some data, it's going to then publish that data. And if the view is listening, then the view is going to grab that data that pops out of the observable pipe, and then it's going to render that on the screen. So that's basically how Model View ViewModel, generally speaking, works. So one of the things to keep in mind about this is that the benefit of Model View ViewModel can also be the deficit. So one of the main benefits of it is we can have a many-to-one ratio of views to view models, and that's because the view model does not depend on any view specifically. The cost of that is that you lose fine-grained control over what the view does. So naturally, in many cases, you're going to have to actually have more logic in your view, because the view is going to have to be able to interpret what's coming in from the observable streams. So there's different ways to solve that, and the logic isn't necessarily going to be super complicated, but this is one of the things you want to think about when you're working with Model View ViewModel in particular. So now that I've given you like a general overview of the pattern, I just wanted to get a little bit more specific about the things I am fond of and not so fond of in this particular architecture, with the hopes that it can help you inform your decision about whether you think it's a good idea to use it or not. So the most important thing, just to start with the cons here, in this particular architecture is that the synchronization between the view and the view model presents a problem of separation of concerns. If you're not sure what separation of concerns is, I've written an article and I'll link it down in the description box below, and it'll basically explain my perspective on separation of concerns. But I actually do consider it to be probably the most important principle to observe in software architecture. Anyways, the reason why the synchronization logic can be awkward, and there are ways around it, is because we don't have that fine-grained control over the view. So this means we have basically two options, and these are kind of what I would consider to be subsets of Model View ViewModel. So option number one is to basically fill the view with a whole bunch of logic to interpret the data which the view model publishes to it. So this approach will allow you to have very reusable view models, but it's going to basically make it so that you fill your fragments or whatever view class you're using with a whole bunch of logic. When you fill something with a whole bunch of logic, that's really the time when you really need to be careful about testing. Now, I personally don't like to test UI classes. Instead, I use humble object or passive view, which basically makes those classes, generally speaking, one-liners, and it makes them simple enough that they don't even directly need to be tested. If you don't take that approach and you want to fill your fragments or views with lots of logic, you will need to probably use Espresso or RoboElectric to make sure that you're testing everything adequately. So one of the ways around this, and this is the key problem, is the presentation logic is awkwardly distributed between the view and the view model. One of the ways around this is to actually make it so that your view model knows a fair amount about the particular view that it's working with. So what I mean by that is it's not that it has a direct dependency, but you can fill your view model with all kinds of, in this tutorial it'll be like live data observables. You can fill it with a whole bunch of these observable fields, which will dictate, for example, should this text box be highlighted or this, that, and the other. Basically details about the view without actually having a direct dependency. So this will allow you to basically pull a lot of logic back out of the view and into the view model, and that's going to make for a much easier to test view. The caveat to doing this is that if you have all kinds of details about a specific view in a view model, even if there's no direct dependency, you are still tightly coupling that view model to that particular view. So you lose the reusability of the view model if you take that approach in exchange for not having to have a whole bunch of logic in your fragments. So with those considerations in mind, which aren't necessarily application breaking, but as you can see, there's not actually a truly specific model view ViewModel pattern here. There's actually some variations in it. And this is something that I've even heard the Android team admit when they were looking into this particular pattern. So as you can see, we've kind of got these different approaches to it, and they're going to have different benefits. So if your user interfaces are like super simple, then you're probably going to be able to get away with having fairly decoupled, unspecific view models. And that's kind of one of the main benefits of this particular approach, is that if you don't tightly couple your view models to particular views, great English here, then you can promote the reusability of those view models. Side benefits is, of course, you are applying some kind of separation of concerns by separating these things out, so you're going to get some benefits to testing and modularity as well. And one important feature, which this is something that's specific to Android's particular tools, so Android architecture components and Jetpack and that, but one of the biggest benefits for this particular approach on the Android platform is that concurrency and lifecycle really is a breeze when you apply this particular architecture and you use their components. So the final, more detailed point I'd like to make on this particular architecture is that if you confine yourself to just having model, view, view model, then you are definitely, well, I won't say definitely, but probably going to run into problems where you have this awkward separation between the synchronization logic of the view model and the view, and you have to kind of pick one path or the other, reusability or not filling your views full of logic. There's actually another solution which you can apply, which is actually what I apply in my production code. I don't confine myself to just using model, view, view model. In fact, most of my architectures, when you look at them, you'll usually see something which is something along the lines of like model, view, presenter, view model. And the view model has a different role. It's not so much a logic class as just a front-end session data container. So anyways, the point of that is just to say here, for the people listening to this, certainly do model view view model and carry it as far as you would like. But if you get into a situation where you have this ugly, awkward division of presentation logic between the view and the view model, another option is to actually create a fourth class, like a presenter. Call it whatever the hell you want. I just call it a logic class. And then you can actually pull out that logic again, decouple it from the view model, and then you can have this sort of fourth object handle things like click events. It's going to simplify your view models, and I would kind of suggest that as you start to build more and more complicated applications. If you're building simple applications, though, usually you can get away just fine with just having the view model in the model. So the last thing I'll be doing in this video is giving you an overview of the package structure of this particular application. So the repository is at Jetpack Notes, MVVM Kotlin, under bracket Cove. Link in the description box down below. And what we'll do is we'll just open up the app module here. Let me just zoom in a little. And I just wanted to talk about what's within the main package here. So we've got 4 primary packages or directories. So within common, you're going to find classes which are shared across different parts of the application. So that's why we have this common module here. So this is where I like to put things like, for example, base classes. So we have a base view model, which is like an abstract class, which shares some code across a set of different view models, constants, and a lot of extensions. So there's a lot of ugly kind of data mapping stuff, and this is something that basically converts from a Firebase task into coroutines, not RxJava, force of habit. And yeah, just all kinds of mappers and stuff like that. So we'll be going into more detail, but I just wanted to give you a quick glimpse there. So that's common. We have the basically two primary features of the application. So we have the login feature and the note feature. Within login, you'll of course find the login activity, login event, login view, and user view model. And then in each of these feature packages, you're going to find a subdirectory called build logic, which will basically contain the dependency injection and user view model factory stuff to create the view models. No Dagger 2 required, so everyone can chill out about that. So anyways, one important point here is that I did actually try to do a single activity approach in this particular application, as per what they suggest in navigation. I was not able to due to tight coupling to on activity result, which as of making this tutorial is not supported by the navigation library. If you're watching this in the future, it may be now, and that is probably my biggest criticism of the navigation library at this point, is that it did not support on activity result, which is problematic. Anyways, I will be demoing the navigation library in this tutorial, but even though I tried to do single activity, I literally couldn't. So there's 2 activities and 3 features. Next, we have the model package. So this is basically going to contain everything which is related to storage and access to data. So we're thinking repositories, implementations, Firebase stuff, room stuff, data models, that kind of stuff. Like I say, we'll go into more detail later. So then we have the note directory, which contains all the different files necessary for the note detail and the note list features. So as you can see here, it's pretty much what we like to call package by feature approach, but something which doesn't necessarily fit into a particular feature, I will put that in a common directory. So within the note package, you see we have the note detail and note list subdirectories, and this will contain the views and view events and build logic for this particular UI screen. And I chose to group them together because they both work on the same conceptual note object. And then we, of course, have the view models and factories and stuff like that for these different views. So that's it for this particular video. Hopefully you learned not just about Model View ViewModel, but a little bit about software architecture in general. And my goal here isn't to crap on Model View ViewModel or to say that you shouldn't use that approach. I think you can build beautiful applications with this particular pattern. What I wanted to do, though, is kind of explain to a lot of the beginners out there who are confused about this particular point that the big kind of consideration with this architecture is that synchronization between the view and the view model can be a little bit awkward. There's ways to solve it, though, and we'll talk about that as we progress through the tutorial. So if you learned something, please do me a favor and hit the like button down below. Consider subscribing and check out options in the description box to support the WiseAss community. So thank you so much for watching, and we'll see you in the next video. Peace out.